Welcome to this video. We are going to look at circuits from an energy perspective and from a potential difference perspective. Here's a battery. Every circuit has a source of charge. The battery will be our source of charge. We're going to connect it by some wires to a resistor. The battery is also going to be connected to this meter, which tells us how much chemical energy the battery has left. Right now, the dial shows 50 joules is left. A battery is a device which separates positive charges from negative charges. We only show the positive charges because in circuits we imagine that there are no negative charges. But actually, they're right here. We're pretending they're not there. We're going to focus in on just one charge, which let's say is 1 coulomb big. Let's imagine the charge has 10 joules of potential energy to start out. The reason it has potential energy is because it's crowded in with a lot of other positive charges. The other positive charges are still there. We're just not showing them right now. When we connect the wire to the battery to the positive terminal, this charge will flow out because the wire is a conductor and because it's repelled away from the positives. So now the wire gives that charge somewhere to go, and it wants to run away from the positives. So it leaves and it travels along the wire. As the charge travels along the wire, we see that the potential energy it has goes down. The reason that the charge loses potential energy is because it bumps into the molecules in the wire, the metal molecules. And when it does, it gives those metal molecules of the wire a little bit of kinetic energy in that collision, and it loses some of its own energy as a result. Okay, the amount of energy lost is small because in general, wires are great conductors. On the other hand, a resistor is not a great conductor. So when the charge enters the resistor, it starts moving along a path, and then it bumps into a molecule, and it bounces off in a different direction, and then it bumps into another, and it keeps bumping into molecules as it travels through the resistor. Every time it bumps into a molecule, that molecule starts vibrating. The molecules are gaining kinetic energy, and by the time the charge gets to the other end, the charge has given almost all of its energy to the molecules through all of those many collisions. It has lost, in other words, nearly all of its potential energy. It only had 10 to start with. Once the charge reaches the other end of the resistor, it's back into the wire, and so it loses only a small amount. It loses the small amount of energy that it still has left. And then it enters the other terminal, and upon entering the other terminal, the battery uses up some of its juice, some of its chemical energy, to give that charge 10 more joules of potential energy. Another way to think of it is 10 joules of chemical energy are used up, and the battery is pumped back up to the higher positive plate with more potential energy. Here's that process again. This time, we are going to simplify, and we're going to imagine when we look at this 1 coulomb charge, we're going to imagine that no energy is lost in the wire, because after all, the wire took away almost no energy. So here it goes, it travels, no energy is lost. It has this convoluted path. With every collision, the charge gives some of its potential energy to a molecule, and by the time it gets out the other end, it doesn't have any energy left. So it loses all 10 joules inside of the resistor. It then returns to the other terminal, where it is pumped back up, and in pumping up with 10 joules, that charge, we use 10 joules of chemical energy. Now, we know that voltage, or potential difference, is the change in potential energy between two different points, divided by the charge that moved between the points. Here's a point, and here's another point. When the charge moves from this point to this point, it gains 10 joules of potential energy. So we could calculate using the potential energy as 10 and the charge as 1, we can calculate the potential difference. Let's change this to delta V right here. It's now going to say delta V is 10 volts, or 10 joules per coulomb. And likewise, down here, at this point, the charge had 10 joules, and at this point, it had 0. So there's a change in potential energy between 2 points. That means we can take that change in potential energy, which is the negative 10, divide by how many coulombs the charge had, which was 1, and we get negative 10 volts as our potential difference across the resistor. Let's look at what the battery does. It converts its chemical energy into electrostatic potential energy, which the charges have. Then the resistor converts that electrostatic potential energy to what we'll call just heat energy. That's not a technical term, but that's the one we'll use for right now. Notice the battery is giving energy. It gave positive 10 joules to the charge. On the other hand, the resistor dissipated the charge's energy. In the language of voltage, we could say the battery supplies voltage or potential difference, and the resistor consumes or dissipates all of that voltage or potential difference.